good morning, afternoon, or evening. Delete as necessary. Today we are going to look at 2.8 multiplication of whole numbers and decimals. And our objective is to review the partial products method for whole numbers and decimals. Alright, so let's estimate the solution to the problem that we're going to have in a second. Write a number model showing how you found your estimate. So we have 3 and 7/10 times 6 and 2/10. So we need to figure out what's the best way to make an estimate for this problem. So, well, let's look at rounding. 3.7. The tenth is in the 7 is a 7, so we have to round up to 4. And then 6.2, we can easily just round down to 6. And we get, multiply, 4 times 6 is 24. So our number model showing our estimate would be 4 times 6 equals 24. Okay, so now we're going to talk about partial products and how using estimates with partial products will help you multiply decimals effectively. So number one, when you talk about partial products, is you want to keep track of place values and multiply left to right. And you're thinking in terms of expanded notation. So 236 is 200 plus 30 plus 6. Breaking numbers into their parts will help you do the math mentally. Multiply one column at a time. Make sure the digits are properly aligned in columns to avoid simple mistakes, and that's true no matter what you're doing. And then write each product on a separate line. So those are the 3 steps that you really need to focus on. Okay, so here's our example. 4 times 236. And here you'll see that each place value, the 2 is in the hundreds column, the 3 is in the tens column, and the 6 is in the ones column. You don't have to write it like this when you do your math. This is just to help you understand that each is a separate column, and then I'm multiplying each number separately. And that if this isn't just 2, but it's 200, right? So that's where I get 4 times 200 gives me 800. Okay, that I could easily do mentally. Now this is also not just 3, it's 3 tens. So it's 4 times 30, which is where this comes from, gives me 120. And here's 4 times 6, and 4 times 6 is 24. And all I have to do now is just add them up. 800 plus 100, 900. 200 plus 20 plus 20 is 40, and 0, 0, 0 is 4. Okay, so the answer is 944. And technically, all of that could have been done mentally. Okay, so let's look at multiplying decimals. So we want to make a magnitude estimate of the product. Then we'll multiply the numbers as though they were whole numbers. Then we'll use the magnitude estimate as a guide to inserting the decimal. So what place value will our estimate will tell us what place value our answer should be in. So 1.3, I'm going to round down, I'm going to round 1.3 down to 1, and 5 I'll just leave alone. So 1.3 times 5 equals 5. So our place value, our answer should be in the ones place, because the answer here is 5. Okay? Alright, so now let's do our multiplication. I'm going to put the decimal point, even though we're multiplying the second step says multiply the numbers as though they're whole numbers. So right now we're just ignoring the decimal. Okay? So with our partial products, this is what I get. I'm going to do 10 times 5 first, and that gives me 50. Now I have 5 times 3, which gives me 15. I add them up, and I get 65. Now, based on our estimate right here, okay, the answer should be in the ones place. So to make this problem in the ones place, I need to put the decimal between the 6 and the 5, because then I have 6 ones and 5 tenths. So it's the estimate that gives you the key about where the decimal is going to go. So now that we are using the partial products method to multiply decimals, we first start with a magnitude estimate of the product. So let's look at our magnitude estimate. Well, let me read through all of these steps first. Make a magnitude estimate of the product. Number 2 is multiply the numbers as though they were whole numbers, not decimal. Ignore the decimal for now. And then lastly, number 3, then use the magnitude estimate as a guide to inserting the decimal point at the correct location in the answer. Okay? So let me zoom in so I have more workspace to work. I'm actually going to change my color to a brighter color. I'll go ahead and just stick with the yellow. Okay. My magnitude estimate first. Okay, let me slide this over a little bit. Okay. 3.4, we round to 3. 4.6, we round up to 5. So 3 times 5 is 15. Okay. So the answer will be in the tens place. Okay. Well, now we are going to ignore our decimals, and we're just going to multiply. Okay. Don't forget, and that's supposed to be a 6. It's a sloppy 6. Don't forget, we're talking about looking at these numbers from a point of view of expanded notation. So we need to take each of these numbers into account. So let's start with, go from left to right, right? 40 times 30. Okay, well, what's 40 times 30? Well, I know 3 times 4 is 12, and then I have 2 zeros on there, so I do 1,200, which means 3 times 4 times 10 times 10, because I have 40 and 30. Okay, so that's where the 1,200 comes from. Next, I'm going to stick with my 40 and go 40 times 4. Okay, so 40 times 4 is going to be 4 times 4 is 16, but then I have 110 in there, so I have to multiply 16 times 10. I get 160. Next, I need to go, basically, since I started with my 40s, I'm going to go over to 6 now. So I do 6 times 30, which is 6 times 3 is 18, but it's 6 times 30, so it's 6 times 3, 18 times 10 is 180. Oops, I'm going to change my... Okay. And last but not least, I have to do 6 times 4. And so 6 times 4 is 24. Okay. At this point, I add them all up. All my zeros plus 4, 4. 6 plus 8 is 14, plus 2 is 16, and I carry my own 1. 1, 2, 3, 4, 5, so 1 plus 2 plus 3, I'm sorry, 1 plus 2 plus 1 plus 1 is 5, and bring down my 1. So I've got essentially 1,564. But remember, change my color, over here, we said that our answer needs to be in the tens place. So how do we make this a 10? Where do we put our decimal point? If we put our decimal point between the 6 and the 4, do we have a number that is in the tens place? Well, no, that's 156 and 4 tenths. Okay, well, we obviously can't put the decimal point here because that's a number in the thousands place. So it can't go here, it can't go here. If we put the number between the 5 and the 6, do we have a number that's in the tens place? We have 15 and 64 hundredths. So that's exactly where our decimal point needs to go. So the answer is 15 and 64 hundredths for 3 and 4 tenths times 4 and 6 tenths. That's a decimal point, so don't confuse that for a comma. Okay. Okay, so what is our big idea? So magnitude estimates help you pinpoint the place value of your answer. The partial products method helps you multiply mentally to solve problems. So I did a lot of my multiplying mentally. I didn't have to do it on written down. Now, of course, you need to make sure that you're confident in your math facts, which is why we practice the math facts so frequently. The same rules apply for multiplying whole numbers. The same rules apply for multiplying whole numbers. Ooh, my editing. Got to work on my editing. That's supposed to be an S applied to numbers with decimals. There's supposed to be an S right there. Sorry, guys. Okay. Also, magnitude estimates are often called ballpark estimates. Estimates that are very rough and used to determine a reasonable answer when an exact answer is not needed. Wow. Okay, so here's a couple of additional problems that I want you to work on in your notebook. Okay, I want you to do 6.3, 6 3/10 times 1 8/10. Let me know what the answer is to that one, and we'll go over it in class tomorrow. And 71/100 times 3 2/100, and see what we get. Okay? Well, thank you very much, and have a good evening, morning, or afternoon.